The universe keeps blinking at us, and for the longest time, we didn't even realize it was happening. Imagine looking up at the night sky and seeing a star that suddenly flares into existence, burns brighter than an entire galaxy, and then disappears almost as quickly as it came. Not for hours, not for days, but in seconds. It's like the cosmos is sending out brief flashes, cosmic Morse code, leaving us to wonder whether we're witnessing random chaos or a pattern we simply haven't deciphered yet. Over the last 2 decades, astronomers have discovered that space is not the silent, steady backdrop we once imagined. It flickers, it pulses, it erupts, and the deeper we look, the more it feels like the universe is winking at us through time. One of the most mysterious examples of this blinking comes from what scientists call fast radio bursts, or FRBs. These are millisecond-long pulses of radio energy that release as much energy in a fraction of a second as the sun does in days. The first one was discovered in 2007 by astronomers analyzing archival data from the Parkes Observatory in Australia. At first, it seemed like a glitch, a cosmic hiccup. But as more radio telescopes came online and technology improved, more of these bursts were detected. Some one-off events, others repeating in strange, unpredictable rhythms. These signals were coming from galaxies billions of light years away, meaning they had been traveling through space for longer than human civilization has existed. It was as if ancient lighthouses were flashing across the void, and we just happened to look up at the right moment to see them. Then there are gamma-ray bursts, the most powerful explosions known in the universe. Detected by satellites like NASA's Fermi Gamma Ray Space Telescope, these bursts can outshine entire galaxies for brief moments. Some last milliseconds, others stretch for minutes. Scientists now believe many of them are caused by collapsing massive stars or the merging of neutron stars. When 2 neutron stars collide, they create gravitational waves, ripples in spacetime itself, followed by a burst of electromagnetic radiation that travels outward in a blinding flash. In 2017, astronomers witnessed this exact sequence. Gravitational waves detected first, then a gamma-ray burst, then visible light from the aftermath. It was the first time humanity observed such a cosmic chain reaction in real time. The universe blinked, and for once, we understood at least part of the mechanism behind the flash. But not all cosmic blinking is explosive. Some of it is rhythmic, almost hypnotic. Pulsars, discovered in 1967 by Jocelyn Bell Burnell, are rapidly spinning neutron stars that emit beams of radiation from their magnetic poles. As they rotate, those beams sweep across space like lighthouse beams. When one of those beams crosses Earth, we detect it as a pulse. Some pulsars rotate hundreds of times per second, meaning they blink with astonishing regularity. These objects are so precise that certain pulsars rival atomic clocks in accuracy. If you were near one, you'd witness a star flickering with mechanical consistency, as if the universe itself were ticking. And yet, despite these explanations, something about cosmic blinking still feels unsettling. There are transient events we cannot fully categorize. Astronomers have observed mysterious dimming in stars like Tabby's star, whose irregular brightness fluctuations sparked speculation ranging from dust clouds to alien megastructures. While natural explanations remain the most likely, the fact that our first reaction was to question whether something intelligent might be at play reveals how strange these phenomena feel. When something in the cosmos behaves unpredictably, our minds search for intention, for agency, for meaning. This instinct is deeply human. We are pattern-seeking creatures. When the universe blinks, we want to believe it is signaling something. But what if the blinking is not a message in the way we imagine? What if it's a byproduct of a dynamic, evolving cosmos? A reminder that stability is an illusion. For centuries, we viewed the heavens as fixed and eternal. The ancient Greeks described the stars as part of a perfect celestial sphere. Even as late as the early 20th century, many scientists believed the universe was static. It wasn't until Edwin Hubble observed galaxies moving away from us that we understood the cosmos is expanding. Since then, Our image of space has shifted from serene to turbulent. Supernovae are another example of the universe's blinking behavior. When a massive star exhausts its nuclear fuel, it collapses and explodes in a burst of light that can briefly rival the brightness of an entire galaxy. For weeks or months, a new point of light appears in the sky where none existed before. Ancient astronomers recorded such events without understanding their cause. Today, we know that these explosions forge heavy elements like iron and gold, materials that eventually become part of planets and, ultimately, us. In a very literal sense, the universe's blinks are acts of creation. Each flash seeds the cosmos with the building blocks of life. Some cosmologists speculate that the universe may undergo cycles of expansion and contraction, blinking on a scale of billions of years. Others explore the possibility of quantum fluctuations at the smallest scales, where particles pop in and out of existence in fractions of a second. At every level, from the microscopic to the cosmic, reality seems to flicker. The vacuum of space is not empty, but alive with activity. Virtual particles emerge and vanish. Fields oscillate, energy shifts. There's also the unsettling idea that what we perceive as continuous might actually be discrete. Some theories in quantum gravity suggest space-time could be quantized, composed of tiny units that give the illusion of smoothness when viewed at large scales. If true, the universe might not just blink metaphorically, but fundamentally. Its very fabric pulsing at scales too small for us to detect directly. For humanity, the realization that the universe blinks is both humbling and inspiring. Each flash we detect represents an event that occurred millions or billions of years ago. We are witnessing history written in light. Every gamma-ray burst, every supernova, every fast radio burst is a reminder that the cosmos is vast and ancient beyond comprehension. And yet, we are capable of detecting these fleeting signals, of building instruments sensitive enough to catch whispers from across the universe. Perhaps the blinking is not a message, but an invitation. An invitation to look closer, to refine our tools, to expand our understanding. Each transient event forces us to confront the limits of our knowledge. When the first fast radio burst was detected, it was dismissed as noise. Now, entire observatories are dedicated to studying them. What we once overlooked as glitches are now keys to unlocking cosmic mysteries. The universe keeps blinking at us, not because it wants our attention, but because attention is the only way we grow. The flashes are reminders that we are part of a dynamic, evolving system. They challenge the myth of a static cosmos and replace it with a vision of constant transformation. In that sense, the blinking is deeply symbolic. It mirrors our own existence. We too flare into being for a brief moment on cosmic timescales. We shine, we learn, we create meaning, and eventually, we fade. And maybe that is the most profound meaning of all. The universe blinks, and so do we. Our lives are brief flashes in an immense unfolding story. Yet during that brief flash, we have the extraordinary ability to look back at the cosmos and recognize its flicker. We are the universe becoming aware of its own blinking. In every telescope pointed at the sky, in every equation scribbled on a chalkboard, in every question asked about a distant burst of light, there is a quiet acknowledgement that the flashes matter, not because they signal something beyond nature, but because they reveal nature's depth and complexity. The more we study these cosmic blinks, the more we realize they are not interruptions in an otherwise calm universe. They are the heartbeat of reality itself. And as long as we keep looking up, listening carefully, and daring to ask what these flashes might teach us, the universe will continue to blink, and we will continue to learn how to see. If we stretch the idea even further, the sense that the universe is blinking begins to feel less like a poetic metaphor and more like a structural feature of reality. The cosmos does not unfold in a smooth, unbroken stream. It reveals itself in bursts. Information reaches us in flashes. Energy is released in spikes. Even discovery itself happens this way. For years, we observe silence, then suddenly a signal appears that changes everything. Consider how often major astronomical breakthroughs begin with something that looks like noise. The cosmic microwave background radiation, the faint afterglow of the Big Bang, was first detected as persistent static in a radio antenna. It wasn't an intentional discovery. It was interference that refused to go away. That hiss turned out to be the oldest light in the universe, a fossil glow from 380,000 years after the Big Bang. In a sense, the earliest detectable blink of the cosmos had been quietly washing over Earth for billions of years before we realized what it was. Then there are magnetars, a rare type of neutron star with magnetic fields trillions of times stronger than Earth's. When magnetars undergo starquakes, sudden shifts in their crust, they release powerful bursts of X-rays and gamma rays. In 2020, astronomers confirmed that at least some fast radio bursts originate from magnetars. For the first time, we connected one of these mysterious extragalactic flashes to a specific type of object. It was like identifying the source of a distant lighthouse beam that had been sweeping across the ocean for years. But even as we solve one mystery, others deepen. Some fast radio bursts repeat in patterns that almost feel deliberate. One repeating FRB was observed to emit bursts on a 16-day cycle, with 4 days of activity followed by 12 days of silence. That kind of periodic behavior forces scientists to consider orbital mechanics, binary star systems, or rotating objects that align just right. Still, the pattern is not perfectly predictable. It teases us with regularity but refuses to settle into complete order. This interplay between order and chaos lies at the heart of cosmic blinking. The universe is not random in the sense of being lawless. It follows physical principles with remarkable consistency. Yet within those laws, complexity emerges. Stars evolve in stages, but the exact timing of their deaths can vary. Galaxies rotate predictably, but collisions can ignite sudden bursts of star formation. Black holes obey gravity, yet the behavior of matter at their edges becomes wildly energetic and luminous. Zooming out even further, entire galaxies themselves can blink in a way. Active galactic nuclei can switch on and off over cosmic timescales. When a supermassive black hole begins actively consuming matter, the center of its galaxy can blaze with radiation. When the fuel runs low, it dims. Astronomers have even observed galaxies that appear to change classification over just a few years, their cores brightening or fading dramatically. On a human timescale, that kind of transformation feels sudden. On a cosmic timescale, it might be routine. There's also the subtle blinking embedded in gravitational waves. When two massive objects like black holes spiral toward each other, they emit ripples in space-time that grow stronger as the objects approach. At the moment of collision, there is a final surge, a peak in the waveform, before the signal fades. Instruments like LIGO have detected these ripples, allowing us to hear the universe in a completely new way. Each detection is like catching a tremor from an event billions of light years away. Space-time itself vibrates and then settles back into quiet. What makes all this so profound is that these flashes are not happening in isolation. They are woven into the structure of cosmic evolution. The early universe experienced a period called inflation, an unimaginably rapid expansion that occurred fractions of a second after the Big Bang. In that instant, space itself ballooned exponentially. It was perhaps the most dramatic blink in cosmic history, a sudden transformation that set the stage for everything that followed. The galaxies, stars, and planets we see today are the aftermath of that primordial burst. Even the quantum world beneath everything flickers constantly. In quantum field theory, empty space is not truly empty. It seethes with temporary particles that appear and disappear in fleeting moments. These quantum fluctuations are tiny blinks in the vacuum, yet they may have played a crucial role in shaping the large-scale structure of the universe. Slight variations in density, amplified over billions of years by gravity, became the seeds of galaxies. In other words, The largest structures in existence may trace their origins to microscopic flickers. There's something deeply poetic about that. The idea that immense galaxies owe their existence to subtle, almost imperceptible fluctuations suggests that blinking is not a glitch in the system, but the mechanism of creation. Instability leads to structure. Variation leads to complexity. Silence, punctuated by bursts, leads to evolution. We are living in an era where the hidden heartbeat of the universe is becoming audible. Each blink we detect is a reminder that we are not passive observers of a silent expanse. We are participants in a grand unfolding story, decoding flashes of energy that traveled across unimaginable distances just to brush against our instruments. And maybe the most astonishing part is this: the universe has been blinking all along. It is only now that we have learned how to open our eyes wide enough to see it.